You done every single question?
Yeah.
Why is not? What's not the notes? Oh, sorry. Maybe next one. This one. AirDrop.
Oh, what?
No.
Oh,
This one. Okay, this paper. First one. Okay. This one is the no problem answer. Okay, and X is the 1 point. Okay, be cautious the step one. Okay, this step got 1 mark. Another. Okay, no problem.
yeah.
Okay, and for question two. Okay, the question two. Okay, first one. There's the 2 marks. Okay, be cautious. Okay, so we need to write down the more complete answer, right? Okay, first. Okay, we need to use what? The answer is right. Okay, and be cautious. Use the value. Use the 10/1. No problem.
Yeah.
Understand?
Okay.
Okay. And second one, okay, we calculate the area, right? Okay, using the triangle. You use the triangle, okay, and times the trapdoor, right? Okay, no problem.
Yeah.
This one got 3 marks. Okay. And for final one is like we will using the motion. Okay, no problem answer. Okay, this one analyze the motion. First one is like mg cosine theta. Okay, analyze the force. It's like mg cosine theta. No problem.
Hmm.
Okay, and then simplify. No problem. 2 marks. And this one, ma. Okay, is the acceleration. 1 mark. And is the g over 13. Okay, it's the 5 minus the 12 mu, right? Okay, and the final, the answer, the g. No problem. And this one, simplify. The question C, you calculate the coefficient is the 5/12 taking away. So the conclusion is like it must be remain at rest.
Yeah.
Okay, no problem. Maybe we can got this one if write down this one this way. The greater than, okay, greater than equal, okay, 5/12, right? Okay. So if the coefficient, okay, greater than and equal the 5/12, okay, then okay will remain at rest. Okay.
Okay.
And the next one, the four step. Okay, first step, calculate the position, no problem. And this one is the C, the answer. Okay, no problem. And part B, the speed is the 4. Speed is 4 is the position vector. Okay, the C. Okay, and you substitute. Final the like okay the squirrel. No problem. And this one you calculate the V. Okay, no problem. Answer. The projection line. This is the projection. Okay, projection. Projection. This one you calculate the using first make the component of the horizontal. 35 times the cosine theta. Okay, times t got the horizontal. Okay, the horizontal is the OA, right?
Yeah.
Okay, 1 mark. And take the answer into it. So using the formula, this one, and take the vertical component. Okay, vertical component using the initial velocity of the vertical velocity and taking it. And final is the x, the time becomes x over. Okay, 1 mark. and simplify. Then we got the 1 is 1 over 13. Okay, no problem. For part B, okay. Part B is the O of the 3 O over 4x, okay, minus 1, and landing, which means the y is to 0, no problem. And this one is the low, so got the OA, okay, no problem. Final one is the maximum height, right? Okay, so we need to label the maximum height. Okay, so the trajectory parabola, the using this one, and takes the maximum. So, okay, you using differentiation, right?
Yeah.
No problem. And height, you use height this one. Okay, no problem. Maybe because this is the projector, okay. So
Yeah.
for the projector, maybe we can use the vertex formula. Okay. Also applies for the answer, right? No problem. Vertex formula. And for the D, your answer is the axis greater. Okay, come here. Because the air resistance will down the upward velocity and the resistance in the lower height, okay, reached, in the lower height reached. The answer is one. You mentioned the air resistance, okay. Will slows down, reducing vertical, okay, and limiting, no problem. And the final one, the ground, the model to be the perfect, okay, flat. Perfect flat. The model assumes the air resistance as a constant. As the constant. What do you mean? This your sentence. This one, your statement. The ground model to be perfect flat. Perfect flat, which may not be the case in actually, or maybe we can see the model, okay, assumes air resistance. Assumes air resistance, okay, has constant, okay, has constant magnitude, okay, no problem.
Oh, okay.
But we need to mention that, but in the reality, okay, but the real air resistance, the real air resistance, okay, depends on, okay, depends on what? Depends on speed of the story, right? Okay, no problem.
Okay.
Okay, the answer is more complex. Okay, and the question 6. Okay, this is about showing the uniform for the part A. Question part A for the unit. This is the uniform road. Okay, AB. For uniform road AB is the mass M. Okay, and tangent. First we know the tangent. Okay, and then you take it using the clockwise. Okay, but you can see the answer is 3. Okay, so first we need to use in a moment. Okay, clockwise the moment. Okay, equilibrium cos equal to the anti-clockwise, right? Okay, so the S1 and this one. Okay, and simplify, no problem. But your answer is too simple. Okay, so we need to mention this one. Okay, for equilibrium, the condition to interpret the condition. Understand? For equilibrium. So we got the clockwise, right? Clockwise actually equal to the anti-clockwise, right? Okay,
Okay.
no problem. Add this one, okay. Got another mark, right? Because it's the 3 marks, which means we have 3 different marks, right? Okay, different point. And B is like, okay, to find the limiting. First, you list the equation. Okay, no problem. And R plus the 2 over 5 mg times equal to the mg. Okay, right. And then simplify and got the answer is the 19 over 12. Okay, no problem. And take into the horizontal. This is the horizontal, like the substitute, and take the mu. Okay, no problem. Okay, mechanical paper for almost there's really no mistakes. Okay, no problem. This one.
Yeah.
Okay, and I will send you another paper. Okay, for the 2020. Wait for a second. Okay, let me sure. Okay, this paper is about the mechanic paper. Okay, for the 2023. Okay, analyze every single moment. Okay, and for every let me quick. Okay, we need to quick to got the answer and quick got the how to finish response the answer, right? Okay, first one.
Yeah.
The car arrest. Okay, rest on the street horizontal road. Okay. For the two questions, how to solve it? You tell me. Tell me the ideas.
Uh.
Okay, tell me the ideas. Okay. First, the car arrest. Okay, initial arrest. Initial arrest. And then accelerate. Okay. The speed, the final speed. Okay, this is the final, right? Final speed. So can we using a motion formula, right? Okay. Motion form like the V actually U plus the AT, right? No problem.
Yeah.
This is question A. Okay. And question B, the distance. Okay. How to using which formula to calculate the distance in the first 5 seconds?
Use 1/2 times the speed times t.
Okay, so we're using the motion, like the distance, right? Okay, the initial velocity t plus the 1/2 and the a t squared, right? Okay, it's formula, right? Okay, no problem.
Yeah.
Okay, the question B. Okay, question 2. Here's the two forces acting on the point P. The particle, okay, mass is 5 kilograms, and the particle is held along the rod. Okay, this is a rod. The rough horizontal plane by the horizontal face of the magnitude of the 28. The only resistance to the motion, okay, only resistance to the motion, okay. The problem,
Yeah.
okay, the motion is the friction, not force of the magnitude, okay. First one, find the magnitude of the normal reaction of the plane. Normal reaction of plane. If they understand this one. And for question B, the particle is accelerating along the plane. Okay. The acceleration is the 1.4 meter per second square. Okay. And to find the value f, using which formula to find the value f? Using which formula to find the value f?
yeah, MA equals F minus 28 minus mu mu 5G.
Yeah. So for this one, okay, and we using the resulting force, right? Newton second law, right? Okay, is the 28 minus F, okay, actually equal to the mass times the acceleration, right? Because we already know the acceleration is 1.4, right? Okay, no problem. And the mass is 5, right? Okay, take it, substitute, okay, finally we can get the F, right? It's 5 times 1.6 or 1.4, okay, no problem.
Yeah.
The minus, okay, plus the 24. Okay, this one is actually to the 7. Okay, it's the 21. No problem.
Okay.
And the fourth question is C. The coefficient, okay, the coefficient of the friction between the P and the plane is mu. Find the value of the U giving your answers. Okay, find the mu. Okay, the friction. Think about how to find the friction. How to find the friction? You got the coefficient mu. No problem.
Yeah, mu times 5G.
Yeah. So we need to using the which formula? Actually, we know the if we calculate the friction, right, we know it times the R, right? Okay, the number reaction, right? Okay, and separate, okay, the F and over number reaction, right? Because number reaction equal to the weight, right? Okay, and take it, finally we can get the coefficient mu, right? No problem. Understand?
Yeah. Yeah.
Okay. This one is the motion. The motion. We already know the velocity. Okay. First one, to get the speed. Okay, how to get speed? How to establish a relationship to the vector of the form of the velocity and the speed of the p.
Just sub the 0.
Okay. First one, we actually know the speed, right? Okay. When the t equal to 0, right? And take it, okay. Taking it so we can get the vector form, right? Okay, like the 7i and the plus the -3j, right? But the topic want us to calculate the speed, right? Speed, which means the square, right? No problem. Square
Yeah.
root
Yeah.
7 square and plus the -3 square. Okay, understand?
Yeah.
No problem.
Yeah.
Okay, this one. And for question B, question B is like the value of the t when p is moving parallel. Okay, moving parallel. Okay, parallel to the I and j. Okay, the value t when p is moving parallel to the I plus j. Okay, think about how to interpret the condition. Parallel, parallel. How to get the parallel? How to explain the parallel? It's like a p parallel. P parallel to I plus j line. Okay, so parallel, which means the parallel vector have the equal component line, like a parallel vector. Okay, have equal. no problem. No problem. Understand? Okay. No problem.
Yeah.
So have the equal, right? Okay. So we can take it double t squared minus 3 and equal to 7 minus 2t the cube. Okay. And then take it. It's a 2t 3 plus the 2t squared and the minus 10, right? Equal to 0, right? Okay. And then eliminate 2 and plus the t squared and the minus 5. Okay. No problem.
Wait, where did the t cube come from?
What?
The t cubed. Where did it come from?
T cube. Where's the t cube?
You read the t
Which part?
cube, but where is it from? Like 7
Oh,
minus 2t cubed.
I mean this one. We know first one the p is parallel, right? Okay. What is parallel? Parallel, which means that we have the equal component, right?
Yeah.
Parallel. Okay. So I established the equation as one. Okay. No problem.
But where is the 7 minus 2t cubed?
Uh, 2t squared minus 3 and equal to 7. And I shift to the left. No
Oh,
problem.
okay. Okay.
Okay, if you shift to the left, okay, and then I can got the 2t cube, right? Okay. The degree is 3, right? No
Oh, yeah.
problem.
Yeah.
This one, if I shift, okay, shift to left side, right? Okay. And then master 10, okay. Find out eliminate 2, right? Okay. The form become this one, okay? Now understand?
Yeah, okay.
Okay. And then think about how to solve it. We need to test, okay, we need to test the positive real root, right? If we take, okay, take the t, if we take the t, okay, like the t, the cube, right? Like the 5 minus t squared, right? Okay, if we take the cube root, okay, like we can got the 5 minus t squared. Understand? Okay, the cube root, right? No problem.
Yeah.
Okay, and then can we using the trail, right? Okay, to check. Okay, to check the answer, right? The t, no problem. Take into the calculator, right? To calculate t, no problem. Okay, and we can get the t. Actually, approximate the 1 point. This one satisfy the equation. Okay, no problem.
Okay.
And for the question C, question is like we need to differentiate, okay, the velocity equation to get the acceleration of the p. Okay. For the question C, we need to differentiate. Okay. Okay. So first differentiate. Differentiate to B, right? Okay. With respect to the T. Okay. So we can get the A actually equal to the dV over dt. Understand? Okay. And then differentiate. Okay. It's the 4. It's got the acceleration. Oh, it's the 2I, a 2t, okay, minus 3, right? I, no problem.
Okay.
And plus the 4t and j, understand? Okay, no
Yeah.
problem. Okay, And for the question D, is that the value, okay, the value of the t when the direction of the acceleration of the p, okay, the value of the t when the direction of the acceleration of the p is perpendicular to the I, right? Okay, perpendicular to the I, this one. Okay, how to calculate D? D is that because there's the condition is like the perpendicular line. Okay, so perpendicular, perpendicular. The perpendicular, okay, to I. That means I component of acceleration, okay, to the other one, okay, and then so we can use in the 4t equal to 0, okay, so we can get the t equal to 0, right? Understand? And the t to 0. Understand?
Yeah.
No problem.
Okay.
Okay, so this part, okay, no problem now.
Yeah.
And then continue. For question 4, a particle P, okay, a particle P is moving on the smooth horizontal plane. The particle has the constant acceleration is the 2.4 I n plus j, okay. And when the t is 0, P passes 0.8. Okay, at time t is the 5 seconds, okay, and P passes 0.b. The velocity of P passes through A, okay. First one, we need to get the speed, okay. Think about how to solve the speed when it passes through B. Think about and tell me. Understand?
Yeah. Use integration.
Okay, so we can use the integration, right? Okay, for this one, I use the integration. Integration what? Acceleration, right?
Yeah, acceleration.
Okay, acceleration. But this is the it's a constant. But this is the constant acceleration. If we integration, we can get the constant, right? And then you mean you take the constant into the equation, right? The point, okay.
Yeah.
So can we use the formula for the uniform motion, like we know final velocity equal to the initial velocity plus the at? Can we use this one? Because t is vector, right? Because t is scalar, okay. Understand? We know the velocity of the p when it passes through. Okay, this is the final speed, right? Okay. Understand? Okay. So like the final, like because the final equal to the negative 16, okay. If I shift, okay, the initial, okay, 16i and minus the 3j, okay, understand? And times the t when t is 5, okay, and 5, okay, 5 the 2.4 I and plus j, understand? Okay, no problem.
Yeah.
And simplify, we can get the vector form of the final velocity, okay. It's like the negative 4i, okay, and plus the 2j, no problem. Okay, and then use the modulus form, okay. Okay, understand? No problem. Understand?
Yeah.
So using the square rule, -4 square, okay, plus the 2 square, okay, and then it's like that we use in the set the 4 square, okay, and plus 4, okay, and equal to the square root 20, and equal to 2 at the square root 5. Understand? Okay, this is question A. No problem.
Yeah. Okay.
Okay, and for the question B. Question B is that the position vector of the A, okay, is the 44i and minus the 10j, okay, the meter. At time t is the t second, okay, and where t, okay, the big T greater than 5, and the P passes through the point C, passes the point C. The position vector, okay, of C, the position vector of the C, position vector of the C is 4i and plus the Cj. The first one, we need to find the value of t. Find the value of t. Okay, think about how to find the value of t. And you tell me. And you tell me.
Use I first.
Okay, so we can using, because the t greater 5, okay, we know the t greater 5, okay, with the position, okay, the position x equal to 4, okay. So can we use in the position vector form? First, we can use the position vector form, okay. No problem.
Yeah.
The formula, okay, like the r, the t equal to initial, and plus the ut plus the 1/2 and at squared, okay, no problem. We only use the I component only. Okay, understand. So for the Rx equal to the 44 minus the, take the substitute into it, the 16t and plus the 1/2 and the 2.4 and t squared, and simplify it. So I can go to the 44 minus the 16t and plus 1.2 t squared. Understand that? Okay.
Yeah.
And we can set, okay, first we know the set the is the 4, okay. So Rx is the 4, okay. Rx is the 4, okay. And take it into it. So I can get 1.2 t squared and minus 1.6 t, okay, and plus the 44 actually equal to the 4, right? And then we can rearrange it. It's like 1.2 t squared and minus the 16t and plus 4, okay. Okay, in that step, okay, think about we use which formula to calculate t. Can we use the quadratic formula?
Yeah.
Okay. Quadratic formula. Okay. The t equal to and 40. Okay, and this one is square root. Okay. This one, no problem. Okay. Because we gave in and you use the correlator, we can go to the t. Because the big T greater than 5, so we can go solve the t is the 10. Understand? Okay. No problem.
Yeah.
Okay. Continue. This one. For the question C. Question C want us to find the C Okay, the point C is C, the value of C. How to find the C? You guys will already know the point C. The point C. Okay, the points the vector, the position vector form is that the R equal to 4i n plus the Cj, right? At T equal to n10. Okay, and for the J component, okay, so can we use the J component of the position? No problem. Okay.
Yeah.
So Ry actually equals the -10 and minus 3t and plus 1 over 2 times 1 and t squared. Okay. And then we can what? Substitute, right? Substitute. Okay, to what? To what? To t equal to 10, right? Okay. Into equation, right? So Ry actually equal to -10 and minus of the 30 plus the 1 over 2 times 100, right? Okay, actually equal to -40 and plus the 50, okay? And it's the 10, right? So thus we can got the C equal to 10, right? Understand?
Yeah.
Okay. And for question 5, this is a projection question type. Small ball, okay, we already know the initial velocity and the angle, inclined angle. And the point A is the 40 horizontal part, is 40 meter horizontally, and 20 vertically from the point O, as shown in the figure 2. The motion of the ball, okay, the motion of the ball from O to A is modeled as that of the particle is moving free under gravity. Given that the ball is projected, okay, at an angle alpha to the ground, okay, use the model, okay. First one, to show that, okay, the 10 over 7, 10 over 7 times the cosine alpha, okay. So for this one, we can use the horizontal motion line. For this one, okay, graph, horizontal motion line. No problem. Like we know in the horizontal, we do the constant speed motion line. Like the x equal to the mu x times t. Okay, understand. And then 40 equal to 28 times the cosine alpha times t. Understand? Okay. And rearrange, we can get the t equal to 40 over what? Over 28 times cosine alpha, right? And simplify, got the final answer, 7. Understand?
Yeah.
The two steps. Okay. And for the question B, the top one asked to show that the tangent alpha squared, the analytical quadratic form, tangent alpha squared minus 4 tangent alpha and plus 3 equal to 0. Okay, for this form, okay, how to establish the form? Well, from the graph, we already know, okay, in the vertical direction, okay, we do the uniform linear motion, right? Okay, so we can use in the vertical component. Vertical component. Okay, we can use the formula, okay, because in the vertical we do the this one, okay, equation like the y equal to u1 times d, okay, and minus 1 over 2 ng t squared. Understand? Okay. And also we got the y equal to 20 from known quantity, and the g equal to 9.8. Okay, and taking into the equation, so we got 20 equal to 28 times the sine alpha and times the t, and minus what? 49 over 10 and times t squared, right? Okay, no problem. And then we can substitute. So we can substitute. Okay, like the t equal to the 10 over the 7 cosine alpha, right? Understand? And then simplify, substitute, okay. Got the 20 equal the 28 sine alpha, okay, and times the 10 over what? Over 7 cosine alpha, and then minus 49 over the 10, okay, and times the t. The t is the 10 over 7 cosine alpha square, right? Okay, the format, and then simplify. Okay, simplify each term. No problem. Okay. So after we simplify the each term, like the 24 times the 10 over 7 actually equal to 40. Okay, like we can also get the 10 over the 7 cosine alpha square and equal to the 100, like 49 cosine alpha square, right? Okay, I can also transfer the 49 over the 10 times the 100 over the 49 cosine alpha square, right? Equal to 10 over cosine alpha square, right? Okay, and then continue simplify. So we can get the 10 times the 1 plus the tangent alpha square, right? Okay, and then continue simplify. So the equation will become what? Become 20. Okay. Left side is 20. The right hand side is the 4d times tangent, and the minus 10 times 1 plus, okay, tangent alpha square, right? Okay. And then both sides we can divide by a term by 10, right? So can got the 2 equal to 4 tangent alpha and minus 1 minus tangent alpha square. No problem. Okay.
Okay.
And shift it to left side. Final, the answer is complete. Tangent alpha square and minus 4 tangent alpha 3 equal to 0, right? Okay. The form, standard form. No problem.
Yeah.
Okay, this standard form is right. Okay. And then here's the question C. Okay, question C is like we need to find, okay, to find what? To find the greatest possible height, the greatest possible height in meters. Okay, to find the greatest possible height in meters, all of the ball above the ground as the ball moves from the 0 to 8. Okay, think about how to find the greatest possible height. Mm-hmm. Like like we need to solve the quadratic, right? We need to solve, okay, we need to solve the quadratic, okay. Solve quadratic. Okay, like we need to solve the tangent. Alpha squared minus the 4 times tangent and part 3, okay, equal to 0, right? Okay, and then we can factorize, okay. Factorize, we can get the tangent alpha minus 1 times the tangent alpha minus 3, okay, equal to 0, right? Okay, so we can get the tangent.
Yeah.
Alpha equal to 1. Okay, or maybe the tangent alpha equal to 3, right? Okay, and then we can get the maximum. We can get the maximum height. Maximum height formula. Okay, like the h equal to u sine alpha squared over double g. No problem. Understand?
Okay.
Okay, no problem. So we can get this one, and then like we know if we have the larger sine alpha, okay, we're giving the larger height. Okay, so we take the tangent alpha equal to 3. Okay, like we can get the right angle. Tangent alpha equal to 3, like the opposite side, adjacent one. I'm sorry, this one. Okay, this is square 10. Okay, and so we can got the sine alpha equal to the 3 over square 10. Okay, and taking into the equation, can got the h equal to 28 times the 3 over square root 10. Okay, now square over the 2, that's 9.8. Okay, and equal to the 784 times 9 over 10, like 90.6, right? Okay, and also the 0.5, okay, 6 over 19.6 equal to the, okay, no problem. This is the question C.
Yeah.
Okay, for the final one, we need to state one other limitation of the model. Okay, state one other limitation of the model. This one for the limitation. Think about we need to state what for D. The limitation is what? Think about it. The model has the limitation. It's that the model ignores the air resistance, right? No problem. So the model ignores air.
Wait, but the question
Right.
already says it does not include air resistance. So
Okay. Hmm?
the question D, it
What?
says the model does not include air resistance, and then state other limitation.
Yeah. Okay. No problem. Like we know, actually we know if there's for the no air resistance, right? Okay. In reality, like the air resistance will slow the boat, right? Okay, and also reduces the height, right?
Yeah.
No problem. Understand?
Okay.
Next one. Question 6. Okay. This one is we need to analyze the force. Okay. The road AB has the mass. It's the M. Okay. and the length is the 2a. The road has its NA on the rod. Okay, here's the rod. Rod horizontal graph. The road makes the angle theta with the ground, as shown in the figure 3. The road is at rest in limiting equilibrium. First one, stay the direction left, and the frictional force acting on the A. Okay, the direction is what? On the A. The A. The friction is left or right?
Right.
It's left or right?
Right.
Why the direction is right?
There's a reaction force on B.
Yes. Okay. For the second question, the magnitude of the normal direction, okay, the S, and in the initial model, the road, okay, is modeled as being a uniform. Use the initial model to answer the part B, C, and D. And for this one, okay, we also need to take in the moment, okay. Taking the moment to show that, okay, here's the marker 3. Okay, so if we want to take in the moment, okay, so taking the moment at point B, point A. So first we know the weight, okay, here's the weight. The weight x the midpoint, okay, so we'll produce the clockwise, okay, we'll produce the clockwise moment. Okay, the moment is like the mg, okay, and times the horizontal distance. The horizontal distance like the a, that is 1. A times what? Times the cosine theta, right? Okay, no problem.
Yeah.
But we also have the normal. The normal reaction, okay, as horizontal left on B, okay, at B. So we'll produce the anti-clockwise. Anti-clockwise. Okay, for anti-clockwise, like we have the value is what? The S, right? Okay, and we want to get the horizontal line. No problem. Use 2a times what? Times the sine theta, right? Understand?
Yeah.
No problem. Okay. Hello?
Yeah.
Okay. And for the equilibrium, it's like the clockwise. Clockwise equal to the anti-clockwise. Okay, like we got the mg times a times cosine theta. Okay, and equal to s times the 2a sine theta. Okay, and we can cancel a, right? Okay, cancel if we cancel a, we can get mg cosine theta actually equal to s times the sine theta. Okay, and then s equal to the mg and cosine theta and over the 2 sine theta. Okay, no problem. And then, sorry, like the 1/2 simplify, got mg. Transfer this one become the cotangent theta. Okay, no problem.
Yeah.
Understand?
Okay.
Okay. And for the question, okay, the C. C, we need to find the value of the coefficient. Okay, it's easy because we also know tangent here, the 3/4, like, okay, the cotangent theta is like the 4/3. Okay, so we can use in the 1/2 times that substitute mg times the 4/3. Okay, equal to the 2/3 and times mg, right? Okay, and then we can use the force balance. Force balance, okay. Like the horizontal friction, like the F equal to S if the 2/3 mg. Okay. And the vertical, like the ground lumbar reaction is the R equal to mg. Okay. The limiting is the force, and then taking is the mu mg equal to the 2/3 mg. Understand? And here's the mu. Mu is the 2/3. Understand?
Yeah.
No problem?
Okay.
Okay. And then for the question D, like to find in terms of mmg, the magnitude of the resulting force, okay, acting on the road at A. In the new model, the road is modeled as being non-uniform, okay, with the center of mass the closer to B than it is to A, okay. So for forces at A, okay, now we can using the vertical, long, like the R actually equal to the mg. So horizontal friction. The friction F equal to the 2/3 mg. Okay, and here's the resultant magnitude is the force, and take it into squaring mg squared plus the 2/3 mg squared, right? Okay, and then it's the mg times take the factor 1 plus the 4/9. Okay, and then we can got the answer. No problem.
Okay.
Okay. And for the final one will also need to state whether the new value, the new value for the S is larger. Okay. Larger, smaller, or equal to the value S. Okay. We'll take using the initial model. Okay, give the one reason for this one for the E. Okay. The E, like think about the new value of S is greater or is larger or not, or smaller, or maybe equal. Think about it and tell me. Mhm.
Uh,
Think about it. Hello?
yeah.
The new value is larger. Why is larger? Because we know from the equation the clockwise moment from a weight, right? Okay, about A increases, okay, as the CMO moves closer to B, right? So the anti-clockwise moment, okay, from wall reaction as, okay, must increase to balance moment, right? Okay, so here S increases, right? Understand?
Yeah.
No problem.
Okay.
Okay, so this is the all of the whole paper, okay, and I will send it to you, okay, the two paper, and then I will send you to another paper, okay, another paper for mechanic and statistic, okay,
Yeah.
and then so today, tomorrow is the final exam, okay, so today you need to finish, okay, all the paper, okay, and recording, right? Okay, no problem.
Okay.
Take all the paper and review it. Okay, I send to you.
Yeah.
Bye bye.
Okay. Thank you. Bye bye.